Rumor was the homework was too easy. I love- that was not my experience. Thank you, Orange Belt.
I almost put Cheerios in it, but I decided
Did you?
against that.
Have fun with your homework. It's gonna haunt your dreams tonight. Trust me, you're glad you don't have that homework. Way worse. Way worse. I think, because I haven't thought about it yet. All right, so let's go through that and then introduce the stuff for next week. Now, is next week our last class? Week after last class, okay. Which is during our spring break, so next week. All right, we'll figure that out. Yeah. All right.
I'm still sure that next week is last week.
Now, I think we've decided that you don't know what you're doing.
No, because it's in the calendar. Like, what do you think?
Whether it is or not, it might be, and I'm not going to be here the week after that anyways.
Oh,
So last week's either our last meeting or we're going to meet an extra week or something, which probably nobody's going to want to do, but I'm away during the undergrad spring break. But one way or another, we'll figure it out. But I'm thinking that there are 8 class meetings scheduled. So however many class meetings we've had, it's 8 minus that we have left. that is how the math works. But we'll burn that bridge when we get to it. Okay, so table printer. Let's go over here. Okay. Whatever. All right, so let me bring up automate the boring stuff. Table printer is from chapter, 6? All right, so this one has to do with organizing kind of doing text-based layouts for things using something that's built into Python for like right justifying, centering, things like that, around the idea of some number of spaces. And inside this chapter, they also added in some things that allow you to ask questions like, is something lowercase, uppercase, things like that. So what can we do with strings, string manipulation type stuff? All right, and then let me just quickly, so let's say I have something like S is equal to hello, and then I print out S. We'll get, oh, well, whatever. I guess we'll just replace that. So we get hello printed to the screen. If I say S are just 20, for example, notice it prints out hello over here. What it's done is it's put 15 spaces on the front of hello because it's saying, okay, I'm going to give you a total character width of 20, and I'm going to right justify S inside of that character width of 20. Okay, we can prove that to ourselves by just taking the string begin and concatenating it onto the front of that, and we'll see begin at the beginning of that. You want to pull that door shut?
Does anyone mind if I dim the lights?
Oh, go ahead. Actually, he can just do it. The third button down, I think. Let's see if that one does the trick.
Is it this or this?
Well, whatever, either one. The bottom one will turn lights completely off. This one. Does that make you happy or not happy enough? Because I don't care. We can go full darkness if you want. All right. So we see I just proved that I just went ahead and concatenated begin onto the front of this guy, and it shows me that, yeah, I did put a whole bunch of padded spaces there. All right. So for this particular assignment, they want you to start off with something that looks like this. And actually, real quick, I just want to drive a point home that came up from a couple of the questions folks were having. And I'll actually do it here. So we'll do def, do something. All right, so I've created a function here called do something that takes no parameters, and inside here it just prints out the value of a variable called s. The problem with this, see, it's going to work. Let's start with that. So down here, which I'm going to refer to right now as the global scope. Scope is where do we have access to a variable. So down here I've created a variable called s, which is equal to hello. Then I've just done some printing of stuff, changing s up. And then I'm calling my do something. Oh. I need somebody in the front row here because in my undergrad classes I have somebody in charge of my spelling errors. All right, so we see here that when I want to print out s here inside of do something, it knew about it. And it's because s lives inside of this global scope. This is a little bit misleading how most computer programming languages would actually work. So if I'm going to write this a little bit differently, I'm going to go ahead and write a function here called main. And I'll go ahead and put that same code here into main. And if down here I call main, main then defines a variable called s, prints it out, calls do something, and now you see s is not defined. It does not know about this variable s here because one was not defined inside of this function and one was not defined inside of the global scope. The only s that lives here is the one that's defined inside of main. And let me kind of draw a picture of that for you here. Python makes scoping rules the default way that we interact with Python, which is kind of like we just start working with, if even you look at the book, it had to do working with the interactive interpreter at first, which isn't even working with a text editor, just having you just feed it Python commands. But now we're just working with just a wall text editor and just hitting play and seeing what happens. What we get is here, let me actually create a slide here that just talks about scope. So we're going to say scope is where we have access to a variable. And then we're going to make a little comment here. Python has a global scope that is automatically given to us. And we've been accidentally using it up to this point by creating all of our stuff inside of this global scope. And that's fine. So in my example here, I'm going to actually create a scenario. I'm going to say r is equal to 5 here. And then up here, I'll print out r. And now we have something that functions again. And I'm going to lay out what scope everything belongs to in here. All right. So in our program right here, we have 3 scopes. We have the global scope, what I've highlighted the whole thing. I'm going to draw a picture of it here in a second. Then we have a scope for main, and we have a scope for do something. So I'll go ahead and give myself our global scope, and I'll make that guy yellow. And I will change the text color. All right, and in our global scope here, we have a variable named r, and we've set it equal to 5. All right, so that's r that belongs in our global scope. Now we have another scope here. The scope for do something. And inside of do something, we have defined no local variables. We could have had a local variable like this guy may have taken in an LOL or something like that, and maybe we pass it the string cat. So now this guy has a local variable called LOL that I'm passing, that I'm passing cat to, but I'm choosing to never use that variable. I don't use LOL anywhere in here. So we'll, just to keep this up there, we'll say do something has a variable called LOL. Now we have something called main. Main takes in no parameters, so no new variable comes from that. We do define a variable here named S. And then we do a couple of things. All right. Now, we might also say that technically in our global scope, we also have main and do something. These are methods that we have access to in our global scope. So everything in the yellow here are things that we have available to us throughout the entire program. This is our global scope. All right. If I am in this blue box right here, I have access to everything that's in this blue box as well as everything that's in the global environment. I do not have access to the stuff from this other blue box. So if I want to just keep the boxes completely separate, we'll make this one an orange box. Well, orange is too close to yellow, isn't it?
If you pass the variable in, do you then have access?
Yep. We're just going to call that good. Yes, so inside of main, I passed a value into do something, and now I have access to LOL in here. But actually what you're asking is, so if inside of main, I said a list is equal to 1, 2, 3, and I passed a list in here. A list comes in for LOL here. I print out the value R for no good reason. And then I say LOL.append 7. And then I print out a list here. You see that now we have the changed version of a list. And the reason for that is a list is a list. Lists, when we pass a list, like we're doing here, to another function, this list is passed by address, passed by reference. So I'm giving this guy a memory address that I'm passing that same memory address in here. So if I were to draw a picture of that, we have the list 1, 2, 3 here. And we know that a list already points to that. So I have something called a list. And when I call do something, which is taking in a variable called LOL, and I'm passing a list for that variable, now I have something called LOL. That points to the exact same place in memory. So when I then say append a 7 to that list, that is happening. Now the method ends, LOL is gone. It lived and died with its scope. So as soon as this scope was over, the variable LOL disappeared. But I still have my original variable a list, which I had actually defined inside of main. So a list actually lives here. And that guy, just to show you, I defined it inside of main. All right, so that guy still lives in this scope, but notice that he was actually connected to the same place in memory that do something changed. So we can access things through pointers in other scopes. But otherwise, if we need one variable accessible from two scopes, we need to make it more global. one way or another. All right. So does this scoping rule stuff make some sense? So one thing I like to do as we get a little bit deeper into Python is create an environment where kind of a common truth we might say in most programming languages is all programs begin and end with main. That's true in C, C++, C#, Objective-C, Java. It's also true in Python. We just, because of the way we start using Python, we're not necessarily convinced of that because we have this kind of super helpful and super confusing global scope thing available to us that makes the idea of passing variables between functions cryptic. Because you can actually access R in here without passing it to the function because R is part of the global scope. So what I like to do if I were to kind of rewrite this Python program, it's actually good enough just as it is right now. But if you want to use Python kind of naming convention, you would ask a question down here. You'd say if this magical variable called __name, which is built into Python, this is for a label, if that guy is equal to __ main, then go ahead and call the main method. This would be what I would call a Python program that visually looks like other programming languages act. So the behavior of this program right here does not change when I have something like that. There are some other values that name can be for different labels that get automatically passed into your Python program. I'm only asking about one of them, so that if statement here doesn't make any difference, but we do notice we do get inside of that. Oh, it doesn't know about R here because I took it out. We do notice that we do get inside this if statement. If we didn't, we would have never called main, and main did get called here. So for right now, just trust me that this will always be true for every one of our Python programs because all programs begin and end with main. And that is built into Python as the core part of the language. So we're just going to say we'll always write this if statement at the bottom of our Python programs. And then we have this thing called main, which I just defined as a random function here. I could have called this whatever I want. I just happened to name it main to coincide with this idea that this main method, this main function is an important part of all programming languages. So the only thing I do in here is I call main. Now that allows me to have a scope associated with the main part of my program and then completely separate scopes for my other functions. It makes my program behave like all structured languages behave. Because another common statement we might make is global variables. It is generally considered that global variables are bad. Now, I'm not sure I agree with that. If we come back here and we say, okay, we understand that all of these guys up here are global variables. Forget about the functions for a second, because in order for us to be able to use the functions, they necessarily have to be global. But if we just think about R in this little example, we could come up with some reasonable reasons why that variable needs to be accessed by both of these functions. Now I have two choices. I can either, as you pointed out, pass it to both of those functions. If they need that value, I can pass it to both of those values. Or I can make it available to both of them by putting it in the global scope. I don't think it's fair to just artificially say it's always bad to have a global variable. Maybe the better statement would be to say, be careful before deciding to have a global variable. For the same reason why things maybe have been confusing when you're dealing with variables and you have access to things inside a function that you didn't define inside of those functions. When you have something global, it's available everywhere. It's available globally, and you start losing track of this idea of why did I define it there. Now, at the same time, you also give up your right to have disconnected versions of that variable. So if I come in here and I say r is equal to 7, and I say print r, I'm going to get that 7 printed, right? Now, if I come in here, I'm actually going to also here at the end of main, I'm going to say print r. So I'm printing r in main after I've already called do something. So do something comes up here and it prints r, then I return back to main and I print r down here. And we see we get 7 both times. Okay? Now, what if I say r is equal to 6 here inside of do something? See, I get a 6 there, but now it's back to a 7 here. When I said r is equal to 6 in here, I got a new, more local version of r. So we say that with variables, all variables boil down to their most local definition. Keep in mind that Python is a loosely typed language. So the difference between defining a variable and changing a variable is not evident. And what I mean by that is if we're in a language, a strongly typed language, and I say int a is equal to 5 versus a is equal to 7, or a is equal to 8, this is me defining a brand new variable by me putting the type in front of it. I am building a container called a, capable of holding one of these, and I happen to be putting a value into it at the same time. Down here, when I just say a is equal to 8, it says I don't have int in front of it. I am, in a language like Java or C++, I'm able to look at this and say, oh, I am not defining this variable here. I am using a variable that I'm presuming already exists. But if I do the same thing in Python, I would say a is equal to 5, a is equal to 8. And we're not able to tell which of these was the definition versus which of these is me just using a variable that's presumed to already exist. Since Python is a loosely typed language where we don't define the kind of value that lives inside of it, we cannot discern just by looking which of those is a definition versus which of those is me just changing or using the value of a variable. All right? What we saw over here is because inside of this function, I changed the value of r to 6. This actually, well, maybe I meant to change the value of r to 6, r being this more global version of r. But instead what I did is I gave myself a new variable which happened to be called r, and I set it equal to 6. I did this. I gave myself a variable there that happened to be called r, set it equal to 6, and as long as I was in here and I said r, all variables boil down to their most local definition. So if I'm looking at this picture, if I'm inside this blue box and I say r, do I mean this r or do I mean this r? My most local definition of r was this one right here. All right, so I said I created a new variable called r, set it equal to 6. I printed it out. I saw the value was 6. Then this method died. And so did its scope. So this value of r disappeared. So then when I went back into main, I printed out a list. Then I printed out r. All variables boil down to their most local definition. R, the most local definition of r, if I look at my thing here, if I'm inside of this orange box, the most local version of R, I look locally, I don't see R there, then I go one step up globally. I don't have access to this blue box from here. I only have access to myself and the global environment. And I see an R up there and I print out the value of R, which was 7. It never got changed. Does that make sense? Now, what would happen if I printed out R first, then changed R, then printed out again? I don't have a variable named R in here. How did I avoid having a variable named R? Well, because I'm inside this if statement. This if statement has its own scope associated with it. That R only ends up existing if I got into that if statement and it lives and dies with this scope. So the whole point of what we're doing here is separating these things into individual scopes so that we don't have this idea of having a global thing. But if I say R is equal to 7 out here, oh, sorry. Start there. Let me just do that for a second. So there's my 7, 7. So R is part of my global scope. I print it out here. If I say R is equal to 6 here, that gives me my more local version of it. So that's my 6 and my 7. But if I just print out R inside of this guy, so the way I got to do something is this guy calls main, main calls do something. This guy has access to R normally. Now if I say R is equal to 6, now it's yelling at me saying reference before assignment. Because I defined R inside of this guy, it's now said, wait, you are purposely choosing not to use that global R variable. I'm therefore going to create a new one. And by the way, you tried to use it before you gave it a value. All right, so the second I chose to participate in my own value of R in here, I can access a global variable. But if I start changing it, I start making things, it's going to say I'm going to protect the global scope, and I'm going to say you actually want a local value. This goes back to this thing here with Python. We can't visually tell the difference between those two things. In strongly typed languages, we can. We can specify whether we're dealing with a definition or a change of a variable. Realistically, good programming practice would probably be don't play this game. If you need a local variable that's only accessible in main, give yourself that variable in main. If you need a variable that's only accessible in do something, give yourself that variable and do something. Only if you absolutely have a value. Maybe you decide, okay, I'm going to have the value of pi, 3.14. It is built into Python, but let's just say it wasn't. And I have the value of pi, 3.14, and I want that accessible throughout my program. Then maybe you say, okay, I'll go ahead and just give myself a global variable called pi, and now I can print out pi in here, and I can print out pi in here, and I have access to it in both places. And we might say that makes global sense because that's a constant. I'm not going to be changing that value, and I want it to be available to everybody, and it's more convenient than me passing it around to all my functions. Does that make sense? Global variables can be okay. Most languages that are strongly typed languages force you or strongly encourage you to set up global variables as what are called constants. But we're effectively using pi here as a constant. We're saying, here's a global variable called pi. Pi's value is 3.14159. That's what it's going to be today. That's what it's going to be tomorrow. That's what it's going to be 6 months from now. I'm going to give myself global access to that variable because that could be handy in my program. That's not a bad use of a global variable there. But the second we start manipulating the value of a global variable, we have to start questioning whether or not that's a smart programming move. Chances are if we have it as a global variable, we're either trying to take a shortcut, which might be okay, but at least question yourself. At least be careful. Make sure that it makes sense for this guy to be a variable as opposed to passing it around through parameters. All right, so that's kind of our scopy lesson thing here. So I'm going to start writing our programs with this structure. All right, so for right now, I'm going to just gut this. I'll gut this. I'll gut this. So we're going to call that kind of our there's our new default hello world program. Oh, sorry. Never actually called main. There's our default hello world program in our new format, which gives us a more structure, gives us structure to a Python program. All right. Now, let's look at table data. So for starters, inside of main, I'm going to go ahead and give myself this table data variable. All right, and we'll prove that this guy's working, and I'll just print out table data. See, it doesn't like indentation abnormalities. But you can create it like this because I want to point out what this guy is. Should let me do that.
I think it's the print that is not.
Oh, yeah. So is print just indented funny? Whatever. Yeah, the indentation levels need to be same. I thought I pressed tab on both of them, but maybe I had an extra space bar before the print. Or one less before it. Oh, won't let me do that. Who knows? All right, so table data here is a collection. All right, so what is a collection or what is a list? Let's talk about it in terms of lists specifically. So a list is a collection of stuff, where stuff is anything that Python supports. So in this particular case, I have a list of, this is stuff at bucket 0, this is stuff at bucket 1, this is stuff at bucket 2. What kind of animal is that stuff? The stuff inside the stuff is a string. What I have highlighted there, what kind of animal is that? That's a list, right? So in our example here, we have a list of lists, where each of those lists holds strings, which in and of themselves are collections, right? So if I come in here and I say print out table data, and I say print out table data at bucket 0, that will give me the very first list, the first thing inside the variable called table data. There's the very first thing inside of table data. If I want the third thing inside of that, 0, 1, 2, 3, that's going to give me banana. And if I want the second thing inside of that, 0, 1, 2, that's going to give me the N. Now, This is not some sort of fancy Python syntax that you have to memorize. Like, oh, what does 2 mean? What does 3 of them mean? What does 4 of them mean? This guy is a collection. Collections can be indexed like this. This guy is a collection. Collections can be indexed like this. This guy is a collection. Collections can be indexed like this, right? Banana is a collection of characters. We call it a string. That's a collection. So we actually have a collection of collections of collections here, which is why I'm able to have 3 things next to each other. It's not like this is some sort of special Python syntax. That's how we index collections. And I have 3 collections here, so I can drop down to the level of a single character inside of this string, inside of this list, inside of this list of lists. Make sense? But this isn't any more complicated than A is equal to 1, 2, 3. I can print out A at bucket 2, and I'll get the 3. But what happens if I say A at bucket 2 at bucket 1? Is that legal? Why not? What is A at bucket 2? What kind of animal is that? It's an integer in this case. Yeah, so it's a number, a 2. Or in this case, it's a 3. It's a number 3. So we have to ask ourselves, what kind of thing is the number 3? It's a number. What kind of things can numbers do? I can't index numbers. I can't say, give me bucket 4 of this number. So that's why this doesn't make sense. It's not that Python has just deemed it illegal. It's Python has said, that doesn't make sense. You're asking me to give you whatever lives at bucket 1 of the number 3. And the number 3 is not a collection. Therefore, this syntax for indexing into collections is not compatible with that. This isn't some sort of special rule you've had to memorize. You're just asking yourself, what are the capabilities of this cup? The capabilities of this cup are very different than the capabilities of this phone. So if I'm holding this phone, I can do a big swath collection of things, right? If I'm holding this cup, I can do a smaller collection of things, although the cups could be fairly, you can throw them and stuff like that. Okay, but I can do a different set of things. So depending on which thing I'm working with here, that dictates what I'm allowed to do. Does that make sense? That's what we're dealing with here. And from a programming mindset perspective, and again, I realize this is like gangbusters, how you're having to get so much stuff under the hood in a ridiculously insane amount of time, and it's just the nature of the beast. But hopefully in the future you'll look back at this and say, okay, at some point in time you heard this material and it may be sunk in a little bit that the code tells the story, not your memory. You don't memorize a language. Over time, if you use a certain language or a certain set of things very, very often, you're going to build up things just from accidentally using it a bunch of times, right? So what are the things you memorize? You memorize those core concepts. How do I define variables? How do I ask questions? How do I write loops, repetitions? Kind of that general syntax. So you can write a function, you can write an if statement, you can write a loop, and you can define a variable. Outside of that, the things that you kind of remember without having to look back up are the things you do all the time. Good example is like, if I had to pick my, language that I know the best, maybe, let's say it's Java or something. But I work with all sorts of languages all the time, but I've been writing Java since it came out. Literally the day the language came out, I was writing Java code. What % of the Java language do you think I have memorized? Since the day it came out. So this is 1993, something like that. What % of the language would you guess I have memorized of Java? 50? Anybody want to go? Oh, you're going to go higher? I wouldn't. I'm going to say probably less than 10%, definitely. Probably less than 5%. What things have I used in the Java language? If you go look at the Java documentation, we'll do it in here. It's fine. Here, I'll just do Java string. That'll get me to the documentation quickly. And I'll go to frames. These are all classes in the Java language. These are all the things that exist in the entire Java language. And if I click on any one of those things, there's going to be a bunch of stuff inside of that. Do you think that I've used a high percentage of those things? Not a high percentage. I've used a percentage of them, but do you think that most programs are made up of easy parts? I've probably done strings quite a bit. I've probably used some of the classes like integer and byte and char and things like that that are built into it, but have I ever had the need to work with the zip input stream class in Java? Not that I recall. Here, we'll pick another one out of the hat. I have used URL, so URI resolver, I may have actually used that. uShort sequence holder, I've never used that one. Now, I can open up that documentation and tell you how to use it because I understand the concepts of a programming language, and I can look at it and say, what kind of animal is this guy? So this guy is a class. And I can go in here and I can say, what are his fields? He keeps track of a value, which is an array of shorts. Here's the constructors we can use for that, and here's a bunch of methods that it knows how to do. So it knows how to read something from an input stream, it knows how to give me something of a type code, and it knows how to write something over an output stream. And then it has a whole bunch of things that inherited from the object. So once I know what kinds of problems I might mean, this is like me walking in the hall of, you walk into Home Depot, you walk into some store, and you see that really crazy thing on the wall. You have no idea what tool that's used for, right? Have you ever been at Home Depot and you wonder what some of those tools are for? I know I do. So that's equivalent to what I'm dealing with here. I use tools from programming languages all the time, but I just walked into Home Depot and I'm like, okay, well, I could use this tool. I know where the handle is. I know kind of what it does, but why would I ever use it? So I would have to go and read this documentation here to tell me what this tool is for. What kind of very specific job was this guy built to solve, right? I've never had to use it before. I still haven't used it, but what I understand about the language would allow me to use it once I was able to identify a problem for which this was the appropriate tool. Okay, so programming is not about memorizing the language. That's what documentation's for, right? You need a tool, you say, okay, I need to do this. And then you decide, well, maybe a quick Google search tells me whether something already exists out there for solving this, or if it's a pretty trivial problem, maybe you should decide, I'll just write it myself real quick to do it, right? But maybe it's worth the time for a fairly complex problem for you to say, you know what? Let's say you're trying to connect to something over the internet, which we'll be doing for next week. You might decide, you know what, that sounds like it could be a little bit complex. There's lots of players involved in that with TCP/IP and the network stack and all this stuff. Wonder if there's something already out there that does that. Because if there was, that would be handy, right? Because like at your house, you have internet at your house, you rely on the little magic cable modem box that gives you access to the internet. You don't care how that gave it to you, but you just know that, hey, I got this tool, I'm giving somebody a amount of money every single month, and I have internet. Somehow. And you're pretty happy with not having to solve that problem yourself, right? Nothing wrong with that. It's the right tool for the job. Programming languages aren't any different. So move your mindset away from, oh, I'm going to try to memorize a language, and instead try to ask the right questions as you're deconstructing things. Like I was saying here, this is a collection of stuff. The stuff that's in that collection are lists. Each of these lists is a collection of stuff. The stuff that's in that collection is strings. Strings are in and of themselves collections. So what can I do with that kind of animal? That makes some sense? All right, so those same questions are going to keep popping up over and over and over again. Now, for table data, we're supposed to do a formatty thing, right? Did I have it up here already? Yeah. So for table data, what we do is we go through and we're going to print out our tables in such a way where we print out the first row is bucket 0 of all the elements in our list. The second row is bucket 1 of all the elements in our list. The third row is bucket 2 of all the elements in our list, and so on and so forth. They've promised us that each thing inside of table data will have the same number of elements in it. Well, they promised us two things. They've promised us that table data is a collection of lists. And they've also promised us that each of those lists has the same number of elements in it. Their example here has 4 elements in it. So we happen to have a collection of 3 lists, each of which has 4 elements in it. This could be a collection of 300 lists, each of which has 7 elements in it. But they've guaranteed us it's a collection of lists, and all those lists have the same number of elements. Okay? And now what they want us to do is they want all of the columns to be right justified, and they want them to be based off of the width of whatever the longest string is in here. So this is kind of an annoying question as a starting point. So how many of you felt frustrated with this question as you were working on it? This is a tedious type question. And what's good about tedious problems like that is it gives us as problem solvers, remember, go back to day 1 of class, we say, why is programming hard for human beings? It's because we're so good at solving problems that we have trouble articulating how we solve them. And this is the perfect example. As human beings, we are not used to immediately jumping into problem solving mode and breaking things down into tiny steps. As human beings, what do? We just solve the problem somehow, whatever that means. Right? Well, this problem forces us, if we want to keep our sanity, this problem forces us to break it down into a bunch of small parts. What are the different things I want to do? Well, if I want everything in this column, for instance, apples, oranges, cherries, bananas, to all be right justified to the maximum length of the longest thing in there, I need to be able to identify what's the longest string inside of that list. And then I can right justify everything to that length. Similarly, if I want everything in this middle column to be right justified to the width of the longest string, I need to determine what's the longest string inside of that, right? And then I can right justify everything. So it might be handy if we went into Home Depot and came out with a little tool that I could drop a list into, and it spit out the length of the longest string in that list. So for this one, maybe if I throw in this list right here, it spits out an 8. Is that the number of characters in cherries? 1, 2, 3, 4, 5, 6, 7, 8. Nailed it. So if I happen to drop this list in here, it would spit out the number 8. That's the longest thing inside of the list. Cherries is the longest string. It started off, it says, okay, well, this guy has a length of 5. What is that, length of 6? This guy had a length of 7. 7 beats 6. 8 beats 7. 6 does not beat 8. Winner is 8. Make sense? So we'll start off by just writing a tool that I can give a list to, and he'll tell me the length of the longest thing in that list. That's all it does. So def length of longest string. I'm gonna really spell this out. Given a list. And this guy's gonna take a list as a parameter. And what it's gonna do is it's gonna go through and it's going to return the length of the longest string in that list. So if I were to give it this first list, I would expect it to return for me an 8. If I were to give it the second list, I would expect it to return for me a 5. This list, it should return for me a 5. Does that make sense? Okay, that's what I want this tool to do for me. All right, well, how do I determine the longest thing in a list? Well, I'm going to go ahead, I'm going to start off with a current winner. And let's just say the current longest thing I found has a length of -1. Very first guy I bump into is going to beat him, right? So now I'll go through every element of my list. So I'll say for, we'll call this list item in a list. And we actually happen to know their string, so we'll call this guy a string in a list. If the length of a string is greater than current winner, if that's a true statement, then current winner is equal to the length of the length of a string. So I'll go through every string that lives in this list. Each time through, I'll ask, is the length of the current string I'm looking at bigger than my current winner? If it is, I'll replace the current winner with the length of the current string. At the end of that for loop, when all is said and done, I should be able to return current winner, and that will give me the length of the longest string in that list.
Why did you say you made it -1?
Just because I know that this guy has a length bigger than -1. If you wanted to go another route here, you could have said, I'm going to go A list at bucket 0. It's my starting winner, and then see if anybody beats him. I just started off at -1, saying the first thing of any length will beat that guy. All right, so we'll test this real quick. So we'll say for list in table data. So for every element inside of table data, what do I want to do? I'm going to print out whatever's returned by length of longest string given a list, and I'll pass it my list. And this should give me 855. Make sense? So I now, see, I'm a cheapskate, right? I didn't actually go into Home Depot and buy this one. I just made it. I made this in the backyard. So I went to the backyard, and a couple of hammers, nails, some pieces of wood, probably some cardboard, some duct tape. And now we have this little tool that I could drop a list into, and he'll spit out the longest string in the list, the length of the longest string. That's a helpful value to me. Why is that a helpful value? Well, if I go back to the drawing board here, as they say, back to the drawing board, when I'm looking at this first column, what do I want to do? Well, I want to make sure all of these strings, which happen to be all the strings in this list, I want to make sure that they are right justified and padded to the longest value in that list. So I should be able to go back through now and make apples padded to 8, oranges padded to 8, cherries padded to 8, which it already is, bananas padded to 8. Make sense? Okay, so now what I can do is I can give myself another tool. Given a padding, an 8 or a 5 or a 5, and a list, make everything in that list right justified to that padding. So I'll give myself another tool. Define, right justify, all elements in list given with. Really spelling out the names of our functions here, right? Okay, because these are incredibly specific tools. This is a one-off. We've made this thing out of duct tape and sticks, and we're probably only going to use it for this one problem, but it does let us break the problem down to small things. So this guy's got to take a list as a parameter and a width. All right, and what I'm going to do is I'm going to say for I in range 0 to the length of a list. And the reason why I'm using the range version of this guy this time is because I'm actually going to want to overwrite the value at a particular bucket in my list with the new right justified version of it. Therefore, I need to kind of be able to say, I want to set bucket 0 equal to the right justified version of bucket 0. So I'll say a list at bucket I is going to be equal to a list at bucket I, which we know is a string, dot r just to width. Make sense? All right, so if I give this guy a list and I tell him the width, I can now go through that entire list and replace every element in the list with itself right justified to a width. All right, I have another tool. So for each of my lists, if I get maybe max length is equal to this guy, so that will be the maximum length of that particular list, right? Then I can go ahead and I can say Oh, actually, I can do that. You were the one who taught me the tab thing, right? 8 star for last week. You haven't earned anything this week yet. Was that last week? You told me tab, or 2 weeks ago?
Last week.
All right. So just justify all elements in the list. My list is called a list. The number of elements is max length. So now I'll right justify it. And remember, just like we had that picture earlier, where I drew my little thing, I passed a list into this function. I changed that list. When that function ended, I still had a pointer to the real place. So this had side effect. I actually changed it in memory. I didn't have to return that value in order for that to have a change. All right, so I'm going to go through every element of the list that you gave me, and I'm going to overwrite each element with the right justified to a certain width version of itself. Make sense? All right, so down here, what am I doing? I'm going through every list in my list of lists. I'm going to go ahead and calculate the max length of each of those, of the current list. That's what this guy does. Then I'm going to tell that list to go ahead and right justify itself to that max length. If I were to then come and print out table data after this, length of a list. Where's my range? Oh, thank you. Notice how these guys now have some padding in them? Because I overwrote them with this function, the right justify function. So I went through and I changed the list in memory to have padding. So now I know that every single one of my strings in each list are all the same length as each other. Apples, oranges, cherries, bananas are all 8 characters long now. Alice, Bob, Carol, David are all 5 characters long now. Dogs, cats, moose, goose are all 5 characters long now. Does that make sense? All right, so now I have everything put together the way I wanted to have it put together. So now what do I need to do? Is I want to go through, and for each of these rows, how do I print out a row? If I'm at row 0, I want to print out this guy at bucket 0, this guy at bucket 0, this guy at bucket 0. If I'm at row 1, I'm going to print out this guy at bucket 1, this guy at bucket 1, this guy at bucket 1, maybe separated by a space, something like that. All right. So I'm going to give myself a function, def, print row, and this guy is going to take in my table data and the row I want to print. And what he's going to do is he's going to say, start off a string as the empty string. We're going to build up a string. And he's going to say, for a list in table data, because we know table data is filled up with lists, right? For each of those lists, I want to say S is equal to S concatenated with a list at position row plus a space. So I'll go through every list that's in table data. I will grab the element from the current row. If I'm printing out row 0, that means I'm going to get bucket 0, bucket 0, bucket 0. If I'm printing out row 2, bucket 2, bucket 2, bucket 2. Make sense? And what am I doing with them? I'm building up a string, putting a little space in between them. I already know that those guys are padded correctly, because I've already doctored it up, right? So I build up my string here. After this loop is done, I'll just go ahead and print out S. That's what print row does. So print row will print out a specific row in there. We can go ahead and test that real quick. So if I want to say print row, passing it table data, and passing it row 0, for example, I'm expecting it to give me something like apples, Alice, dogs for that one. There's my apples, Alice, dogs. If I go ahead and say, we'll just cheat a little bit here for a second. 1, 2. We just happen to know the size of it. That's the output we ultimately want, right? So how did we do this? Well, we're going to need to have a function. What was the thing even called? Print table. So we'll have a function here, def print table, that'll take in some table data as a parameter. And what's it going to do? It's going to go through every element inside of table data and doctor it up. All right. Then what's it going to do? We actually could do it all inside of a single loop, but I'll do it this way. So now that we've doctored everything up inside of print table, what we'll go ahead and say is we need to know how many elements are in each of our lists. And we know that we were given the information that each of our lists has the same number of elements in it. This has 4, this has 4, this has 4. So it doesn't matter which of the guys I ask, I'm saying table data, how many elements are in bucket 0? 4. How many elements are in bucket 1? 4. How many elements are in bucket 2? 4. So I'll just get number of elements. So I'll say number of elements, and I see that it's indented funny here. Is that a me thing? It was a me thing. All right, so number of elements is going to be equal to table data at bucket 0, and I want the length of that list. That'll give me my 4 in our example, right? That's the number of things in that collection. So that's the number of rows that I want to go through, right? I have 4 rows, 1 row for each element in the lists. So for I in range 0 to number of elements, if I maybe instead of calling it I, I'll call it row. For row in that range, what do I want to do? I want to print a row from what? From table data for the current row. That's what it takes, right? Table data and then the row. That's what I'm going to do for each of my rows. So doctor up my table to have all the right padding. Then figure out how many rows I'm going to have. So we can even call this number of rows if we like that better. For each of those rows, print the row given table data and the row we were trying to print. So here we'll call print table, giving it table data. And there's our output. That makes sense? All right. Now, were any individual one of these little problems we solved all that complex if we were only focusing on solving that one portion of the problem? If we were able to block out all the extra noise, right? And say, all I care about is how many characters are in the longest string, and all I care about is making sure all the strings are padded to the right width, and all I care about is printing out one row. If I broke it down into those tiny little problems, I was able to solve my more complex problem in terms of all those little tiny steps. That make some sense? All right, questions on that?
Why did you pass an empty string to us?
Because I'm building it. I'm building a string. So you could have printed it by and then saying, was it print, comma, end equals the empty string like this. So you could say, I'm going to print one thing, then I'm going to print something right after that, I'm going to print something right after that, but print by default, print something and presses enter. So what I did is I built up that string. So I built up apples, followed by a space, followed by Alice, followed by a space, followed by dogs.
So it's
Right.
basically the same function as end in the
Same function as what?
as the tool of end in the print function.
Well, yes, except the print function displays it to the screen. I built it up in a string here. I didn't have to display it if I didn't want to. I could have just printed out LOL, just cause, and never actually printed out my string. I built up a variable called S, which was the contents of my row, and then I chose to display S to the screen after I built it. So that's why I started with an empty string, because I wanted to build up a string from nothing. All right, other questions on this one? Okay, what are we doing on time? So let's take about, 8 minutes or so. Stretch your legs, whatever, then come back and we'll start working on the next one. So I'll upload the videos in pieces.